Hello there. In this video we're going to show you how you can create a Celtic knot earring with a 3-leaf pattern. I'm basically going to use one of the default designs that are available within Fluid Designer for 3D printing. So if you start Fluid Designer up, you need to go to the earrings folder. And if we just scroll down, I'm just scrolling the center mouse button here and just scroll down, I'm looking for Celtic knot patterns. Now all of these patterns here that are in grey, not the white ones, but all of the grey patterns can be manipulated in the same way as we're going to show you with this particular Celtic knot earring. So the skills that you learn in this video can be applied to lots and lots of objects in Fluid Design. Now if you look at these two Celtic knot patterns here, they look quite similar in terms of the icons, the pictures there, but if you look at the numbers, this one is 301 and this is 001. Now I'll just drag 001 onto the screen and show you what that looks like first of all. Well, that's a Celtic knot, but if you look, it's kind of flat in appearance. If I just go to File and New again, okay, so that was 001. I'm going to use 301 in this tutorial, and if I drag and drop that onto the workspace, and I'll just switch on the screencast keys. If I hold down the center mouse button and rock it, you'll see that this object is like a twisted wire, effectively. So it's got depth. So it looks it's got a Celtic knot look there. But it's actually got some depth to it, and we can see that it's about 5 millimeters deep. So the height of it and the width of it are about 11-12 millimeters, but it's got a depth of about 5 millimeters. So that's the difference between 301 and 001. Now there are not very many 300 objects in Fluid Designer for 3D printing, but that's the difference between them. So what can we do with this object? Well, like all objects, we can change the bevel, the cross-section of it. If we go to the Show the Curve Data Information icon, we could change the cross-section to be a square cross-section. We could make it much thicker, or we can make it rounded. Okay, so that's the first thing. I'm going to leave it at the default size, which is 1 millimeter, which should be fine for 3D printing. And then also what we can do is we can use the modifiers icons. We can change the columns. So if I do that, you'll see what I get is initially I get a circular pattern. And the reason for that is because this object here, this angular rotation object, is ticked. If I remove the tick, you can see that we go back to a count of 6. We've got 6 objects in columns. 1, 2, 3, 4, 5, 6. If we tick object offset, we get a circular pattern. Similarly, as well as removing the tick there, we could remove the actual object itself, the angular rotation object itself, and again the pattern will disappear. Now the angular rotation object, if we go over to the outliners panel, is this object here, and it's actually something called an empty, and we just use plain axes empties to actually act as the center of rotation. If I go to the properties panel, you can see that we've got a value set for the rotation of 60 degrees. I could change that to other values. I could change it, for example, to 90 degrees. Now it hasn't made any effect here because the Celtic knot earring, if we go back to modifiers, the object is not selected. I deselected it a minute ago. But if I put it back in now, you can see that we get 4 copies of the object, 4 copies of the Celtic knot rotated around, and they're going at 90 degrees. Now over here in count we've got a value of 6. Now if you tried to 3D print this object, you'd have real problems, because what's actually happening is this is the original object, this is the second copy, the third copy, the fourth copy. The fifth and the sixth copy will sit on top of these two at the bottom, and if you try and send that to Netfab Basic, Netfab will make a complete hash of it. You've got to reduce the count down to 4 if you've changed the angular rotation to 90 degrees. What you should always do if you're doing angular rotation is start off at the beginning there with a count of 1 and work up slowly, and when you see one that doesn't appear, when I click on count 5 there, it's obviously placed it on exactly on top of this one. You don't want that, so you must go back. So you make sure you've only got the right number here. Don't duplicate one. Now I don't want to actually create an earring with any angular rotation in this case, and I don't want to have any columns, so I'm going to set that back to 1 as well. And if I open up this second modifier here, which says set the rows, and I'll just shut that one down a little bit there. If I change the count there, you can see that I've got 1 row, 2 row, 3 rows of this Celtic knot. Now if I wanted to, if I just zoom in, I could change this relative offset and bring them down closer together. You do need to be careful when using 3-dimensional objects that they are overlapping, because obviously if they're not overlapping and not overlapping sufficiently, the object when it's printed could print in more than one part, or it could print in such a way that it easily breaks. So you do want to be careful and look for a good overlap, which we've got here at that setting. Now obviously the other thing to take into account when 3D printing earrings is you've got to consider what the weight of the object is. So if I open up the toolbox panel here, what I'm looking for is a little tab here that says 3D printing. Now our Celtic knots at the moment are in fact curves, and that's indicated by the fact that we've got the curve icon in the properties panel and we've got the curve icon over here in the outliner window. This object is still a curve. You can't actually check curves to see whether or not what their weight is. So what you need to do is you need to confirm these settings, you need to apply the modifiers and convert this to a mesh. And the best way to do that is just to go to Tools, Object Tools, and convert it to a mesh. But you must be happy with the size, the quantity, the position of these objects before you do that. Don't convert it to a mesh with any gaps. So we converted it to a mesh there, and notice that this tab now has appeared, 3D printing. And if we select that tab, and if we just move this panel down, what we'll do is if we run the volume, if we click on volume here, you can see that Fluid Designer has analysed this object, and it says that the volume is 0.1364 centimeters cubed. And anything less than 0.3 centimeters cubed is going to be fine for creating earrings. You can at a push go up to 0.4, but they are going to be quite heavy. So you're looking for a value here, usually less than 0.3, which we've got. Now sometimes when you do this, you might end up with 136 million cubic centimeters. Sometimes Fluid Designer does the calculation wrong. So if you get a number here, a very, very high value, millions of cubic centimeters, it's clearly wrong. And what you need to do is count the decimal point back 3 times, 3 times and 3 times. Count it back 9 times in total, and then read off the volume. In this instance with this object, no problem, that's the actual volume. So we can close the toolbox down now, and I'll just press the T key on the keyboard to do that. Now what I want to do is I'm going to actually add a connector to this. So if I go to view and top view, so what I mean by connector is if I go up here to 3D templates connectors, I'm going to append this particular wire connector here with the 2mm diameter hole. I'm going to add this to the current workspace, and you can't do it by dragging and dropping. If you do that, the Celtic knot pattern will disappear. So what we need to do is to go to File and Append, and we go up through the menu system until you get to Groups. Look for the Groups folder. That's the default folder for all of the patterns that are available in Fluid Designer for 3D printing. And if you then go to 3D templates connectors, go to the folder where the connectors are. I want the wire connector with a 2mm hole, and it's always the object that you need. So I want a wire connector, 2mm diameter hole object, and I want to append that from the other file. And if I just zoom in now, and if I just select that object, what I need to do now is position it. And I don't know quite why it's acting so strange, this, but it is doing. I'll just switch off the snap. Yeah, that's better. And I'm going to position it down there. Now I'm going to press the tab key to go into edit mode, because I want to make this just a little bit shorter. And if I just zoom in, you'll see there's some control points here. I'm going to press X on the keyboard and delete that vertices, and X on the keyboard and delete that vertices. So I've just made that shank there a little bit shorter. And I could just zooming in with scrolling the center mouse button, if I just pull that up now until it just goes into my Celtic knot. So I'm just looking at that point there. Here you can see it's not quite in the Celtic knot completely. If you just keep pulling up just until it goes through the surface there, so that's fitted nicely now. It looks okay on the other side, so you can press the tab key to come out of edit mode there and view it from the top. And so what we now need to do is to join these two objects together. Well, this object that's grey, the connector, is in fact still a curve, and we can see that again in the properties panel because the curve icon's there. So we need to convert that connector, convert that also to a mesh now. And we wouldn't have had to do that if we hadn't converted the earring itself to a mesh. If the earring had been still in a curve format, if we hadn't bothered to check the size of it, we could have joined the two curves together. But you can't join a curve to a mesh. You can join a mesh to a mesh, a curve to a curve. So with the connector highlighted, I hold down the Shift key on my keyboard and highlight the earring itself, the Celtic knot, and then if I go to Tools, Object Tools, I can join them together. Okay, so now that we've got the connector joined with the Celtic knot earring, what we need to do is to save this, but as is usual in Fluid Designer for 3D printing, we don't want to go to File and Save. We need to export it as a printable file format. So export it as a wavefront OBJ format. If I export it to the desktop, I can just delete the text master there. So it's a Celtic knot 3-leaf earring, and I'll leave 301 there just to indicate the fact that it is this kind of three-dimensional shape. So we'll just let that save it to the desktop. Now obviously the volume of this will be slightly larger than we showed you before, so if I just open up the toolbox panel there and click on 3D printing, and I'll just drag that down there so we can see the results. So if I click on volume, you can see the weight's gone up slightly because we've added this connector on, but that's still a perfectly acceptable size there. So if I just go to File and New for a second, so can I just reiterate that the skills that you will learn in working through this video can be applied to many of these objects that are shown here. Certainly all the grey objects can be manipulated, well, most of the grey objects, sorry, can be manipulated in a similar way to the way I've just shown you there, by creating circular arrays and rows and columns of objects. But you do need to be careful with earrings that you don't make the weight of them too much. Okay, so that's it for this video. Thank you.